If the cosmic monsters held dark energy in their cores, then it would be possible to explain how the cosmos and black holes came into existence. The study that offers a solution to one of the most significant problems in cosmology proposes that supermassive black holes may be the engines powering the expansion of the universe. Cosmology is the study of the cosmos and its origins, structure, and evolution. By analyzing the evolution of supermassive black holes over the course of the previous 9 billion years of the universe's existence, astronomers have discovered evidence that the hungry black holes at the centers of the vast majority of large galaxies are the source of dark energy. The unidentified component makes up 68% of the universe and speeds up the expansion of that universe. Two articles, one in the Astrophysical Journal and the other in the Astrophysical Journal Letters, with detailed accounts of the results of the researchers were made available on February 2nd and 15th, respectively. If the researchers who developed this concept are right, it will fundamentally alter the study of cosmology by resolving the question of where dark energy comes from. This is a conundrum that has perplexed theoretical physicists and cosmologists for more than 2 decades now. The rate at which the universe is expanding has been shown to have quickened over the previous century, according to findings from astronomers. This discovery came as a shock considering that it had been hypothesized that gravity, when left to its ways, would eventually result in the Big Crunch. In order to explain the discrepancy, scientists have proposed a concept according to which something more powerful than gravity must exist, and this substance is responsible for driving atoms apart throughout the cosmos as a result. That something was eventually given the name dark energy. Dark energy, on the other hand, would have to be present in such massive quantities that it makes up the vast majority of the universe for it to be able to prevent the collapse of the cosmos. Yet, up until this point, it has not in any way been observed. Researchers just identified something that seems to be the missing piece to the puzzle that has been this phenomenon up until now. A comparison was made between the masses of the supermassive black holes at the centers of 2 distinct groupings of galaxies. The first group was young and distant, sending us light that travels 9 billion years back in time. The second group is closer, being only a few million light years away. The researchers came to the conclusion that since the beginning of time, there has been a massive increase in the size of supermassive black holes across the universe, which cannot be explained by black holes eating stars or merging. The size of supermassive black holes has increased by a factor of 7 to 20 since the beginning of time. They propose that black holes are expanding at the same rate as the universe, with the help of a hypothetical form of dark energy called vacuum energy. This form of dark energy is stronger than the star-crushing and light-capturing forces that are located at the centers of black holes, and as a result, vacuum energy causes black holes to grow. And as they leave, the very fabric of the cosmos unravels after them. Unanticipated results were discovered here, as one of the researchers has pointed out. We started by investigating the formation of black holes with the intention of addressing a significant cosmic mystery. Einstein's general theory of relativity defines how gravity influences the cosmos on huge scales. If expansionary dark energy does truly reside at the cores of black holes, then it will address 2 long-standing issues in the theory. This would solve 2 issues. First, it would eliminate the need for singularities to explain the inner workings of black holes, and second, it would explain why the universe does not collapse due to the massive and pervasive force of gravitational attraction. Both of these issues have been a source of contention in the scientific community. An astrophysical explanation for the genesis of dark energy has just been proposed for the first time, and there is growing evidence to suggest that the conventional approaches to solving the problem of black holes are not enough over the long term. It's not that no one else has ever proposed explanations for dark energy before, but this is the first observational report where we aren't giving any novel explanations for it ourselves. According to Einstein's general theory of relativity, dark energy is represented by black holes. Astronomers will need to keep a close check on the growth of black hole masses over time in order to demonstrate that their theory is correct. They will need to ensure that the expansion of the universe is the only factor responsible for this growth rather than some other factor. What exactly is meant by the term dark energy? Scientists believe that the fast expansion of the cosmos is due to an inexplicable phenomenon that they have called dark energy. There is some evidence that points to black holes as the hiding place for this mysterious force or energy. By acting in opposition to gravity, an unexplained force known as dark energy is responsible for accelerating the expansion of the cosmos. The precise makeup of dark energy has been a source of consternation for physicists for decades, despite the fact that it is believed to account for as much as 3/4 of the mass energy in the universe. Although they have the same word, dark, scientists do not yet understand either dark energy or dark matter, despite the fact that the two have the same name. In the year 2023, researchers asserted that they had found confirmation that the energy from black holes may be responsible for dark energy. If the conclusion holds, it would imply that our current models of the cosmos do not require any additional forces or fields above and beyond Einstein's theory of gravity to account for dark energy. This would be the case even if the result did not hold. However, the findings would first need to be validated by additional investigation before physicists would generally acknowledge them as a viable explanation for dark energy. According to the website for the Hubble Space Telescope, the American astronomer Edwin Hubble made the discovery in 1929 that the further away a galaxy is from Earth, the faster it is moving away from us. This was the first time the idea was put up. Nothing in space is moving closer to anything else, or on the contrary, everything is receding at a rate that is proportional to the rate at which it is moving away from everything else. Around 60 years after Hubble's announcement, scientists made a startling discovery that was equally as shocking. For a significant amount of time, researchers in the scientific community worked towards the goal of accurately determining cosmic distances by utilizing the light from faraway stars. The discovery that the brightness of distant supernovae was lower than predicted was made in the late 1990s by two separate groups of researchers working independently. There is mounting evidence suggesting that the expansion of the universe is picking up speed. Since then, this discovery has had experts scratching their brains, and in recognition of their efforts, the discoverers of this discovery were given the Nobel Prize in Physics in 2011. Even though scientists don't fully understand the phenomena themselves, they have used what they have learned about dark energy to create models of the universe that explain everything from the Big Bang to the contemporary large-scale structure of galaxies. These models could explain everything from the origin of the universe to how galaxies are organized on a large scale today. Some of these models project that dark energy will, at some point in the distant future, billions of years from now, be responsible for tearing everything apart. According to the hypotheses that are now holding the most weight, dark energy is a type of dormant energy that is woven into the very fabric of space and time. This easy adjustment to the cosmological model does not call for any changes to the principle of gravity, and it has been demonstrated to be successful in practice. Having said that, there is a significant problem with this strategy. It is anticipated that the amount of energy contained in the vacuum will be 120 orders of magnitude greater than what cosmologists have measured so far. In February of 2023, scientists were able to verify that these cosmic behemoths are expanding at an accelerated rate by using data that was obtained from black holes that had been quiescent for a very long time. The findings, when interpreted within the context of Einstein's theory of relativity, imply that black holes are in possession of a type of vacuum energy that is intrinsic in the fabric of space-time and that can explain the expansion of the universe. If this turns out to be true, it suggests that the mystery of dark energy could be solved without the introduction of any previously undiscovered physical principles. A competing theory claims that dark energy, in addition to gravity, electromagnetism, and the strong and weak nuclear forces, is one of the 4 known fundamental forces in the universe. Nevertheless, this hypothesis is incapable of explaining why we do not experience this augmented power in our day-to-day lives. As a result, theorists have created imaginative models with the implication that this unidentified force is hidden. In the field of physics, 2 schools of thought that are at odds with one another are having a fierce debate right now about the value of dark energy. By analyzing the cosmic microwave background, which is a weak residue from the Big Bang, scientists have been able to come up with an estimate of how powerful dark energy is. However, other astronomers, who compute the intensity of dark energy by using the light of distant cosmic objects, have arrived at a different value, and no one has been able to explain why. In spite of the fact that certain researchers have proposed the idea that the intensity of dark energy varies over the course of time, they have been unable to sway the opinion of their colleagues.